2011. You guys are on text, page 164 in your blue notebook, page 270. We're back at chapter now. We're going to lesson 4.1. You guys are to copy down nonlinear relations, curve of best fit, and key concepts. Okay? So hopefully you guys have that all down right now. Get rid of this. Okay. First of all, we're going to talk about nonlinear relationships. And instead of actually directly talking about nonlinear relationships, I'm going to talk about the opposite. What would the opposite be? A linear relationship. Okay? So, first thing I'm going to do is I'm going to plot some points. Okay? So, let's say this is a bunch of data I've taken. Could you call this a linear relationship? Yes. You could easily call this a linear relationship because if I made a line of best fit, why isn't it going? Oh, I got to hold it, that's why. If I made a line of best fit, that would be roughly it. We could get a straight line into that. So this would be called a linear relationship. Okay, guys? So this would be our linear relationship. Now, let's see if I give you something like this. I didn't mean to draw there, but could you call this a linear relationship? No. Sure, we could call it many different things. Really don't, actually, we haven't learned what we're going to call it yet, but we know it's not linear, so a good title for that would be nonlinear. Okay? Now, to go along with that, instead of putting a line of best fit, what would I use? A curve of best fit. That's right. So I'm going to roughly estimate this would be a good curve of best fit. Okay? So here we have a line of best fit. Line of, can I call it BF? Is that all right? Boyfriend or best fit? And we'll call this a curve of, oh, I didn't mean to write that. I got to write BF. Forgot. Of best fit. Okay? So we've already shown linear, which you guys would have learned in grade 9. Remember your y equals mx plus b. Those are linear relationships, and we have a line of best fit. Today we're going to start talking about nonlinear relationships and curve of best fit. Okay? So we've seen the difference between the two. Let's go back up to the next thing. Okay. So with that being said, I'm going to make a little bit of stats here. I'm going to put some stats on the board. We're going to say that these stats represent hours studying, so that's going to be our x-axis, okay? Hours studying versus, what do you think y is going to be? Great. We're going to be talking about relationships here, okay? So what I'm going to be doing, first of all, we're going to talk about an independent and a dependent variable. So what that means, an independent variable can be essentially anything. Nothing is affecting it, we're going to say. But a dependent variable changes with the independent variable. So what I'm trying to say is the more or less you do to the independent variable, the more the dependent variable will change. I know that's a little confusing, but I'm going to use hours of studying in grades. Let's just say some teacher you know decided to take stats and did a survey of students and how much they studied. Let's say he did 100 students, okay? So we had 0 to 10 hours of studying. He surveyed 100 students, and he discovered this type of relationship when he plotted all the data. So we found a lot of the students who studied for 3 hours roughly got 10% on the tests. Once they got up to 6 hours, well, it looks like they were passing tests. When you studied for 8 hours, you were around a 70, and when you got to 10 hours, you were getting 100% on the tests, okay? So which would be the independent variable in this case? Does anyone know? Sylvan. Hour studying. Here is our independent variable. Okay? The hour studying. Now, with that being said, what's going to be the dependent variable? Sheldon. Our grades. Very good. Okay? Oh, I didn't highlight. Unlucky. Okay? So we have our independent and our dependent variables. So let's write that on top. Below this is our independent, and this was our dependent variable. Okay? Independent, independent. So it turned out that the more hours you studied, the better your grades got. And it seemed to actually be increasing. It was pretty flat. From 1 to 4 hours, there wasn't really a big change. But once you got after 4 hours, it really started to move up. Okay? Now we have our independent and our dependent variables. When you go to graph something, so you guys are going to get a lot of questions that are going to give you statistics. So they're going to give you a whole bunch of coordinates, and you guys are going to have to plot them. You're going to have 2 statistics. You're going to have to figure out which is the independent variable and which is the dependent variable. Okay? Now, just to go along with this, would you call this a linear relationship? Anybody? Yeah, you think that's linear? Could I put a line of best fit, maybe something, what do you think looks better? Something like this to represent the data, or maybe something like this? Which one do you think works better, the line of best fit or the curve of best fit? Curve. So let's call it our CBF versus our LBF. Line of best fit. So our curve of best fit really represents the data a lot better. Our curve of best fit represented this data. So it was more an exponential. We'll get into that, okay? So what we're going to do, now I know this is really short what we've done so far. Pause this for a second. I want you guys to go to your textbook page. Go to text. Text page 167. Number 4. And I'm going to give you guys about 8, let's say 8 minutes for you guys to try this out, okay? Yeah. Okay, so I'm going to make a graph now for question 4A. First of all, speed and fuel economy. Which one is my independent, which is my dependent variable? Kevin. Is my what? Yes, that's right. So the speed, kilometers per hour, is my independent. So that's going to go on which axis, the independent? The X. Our independent always goes on the x-axis. So if we look at these numbers, for speed, it goes from 10 to 150. So that means I need to make my x-axis, I'm going to get the scale to, the steps to increase by, let's say 10. And I need it to go up to 150. Simeon, how close am I to 150? There we go. Okay. And what about my fuel economy? It goes between, what's the range of my fuel economy when I go to make my graph? It goes from, what's the lowest number we have? 10. What's the highest? 22. Okay. So it goes from 10. So you know what? We can even start our, well, no, we'll start at 0. Am I at 0? Yeah. We need to go up to about 25. And we'll go up by, should we go up by 1? Yeah, we'll go up by 1. Okay? So, here's going to be my graph. I'm going to have to bring it down. I'll delete this one. Get our graph here. Okay, so we're dealing with question number 4. Okay, it tells us to make a scatter plot graph. So we have to plot all these. And so we've plotted all of our points. We put them down. Quickly, at first glance, is this a linear relationship? No. So what is it? No, what's it called? Non-linear. So we know that right away. We know this relationship is going to be non-linear. Okay? And if I needed to draw some type of line or curve through this, would I use a line of best fit or a curve of best fit? Curve of best fit. So I'm going to do my best right now, because we know my dexterity is not great. Oh, you're killing me. You walked right in front of me. Yeah, that was all right. That would be our curve of best fit, CBS, okay? There's our curve of best fit. So what 4A says, make a scatter plot of the data. We did that. Describe the relationship. There's our B. It is a non-linear relationship. Draw a curve of best fit. Amazing. We've already done that. C. What does D say? Use your model to predict the fuel economy at 200 kilometers an hour. Woo! I should have extended this graph a little more. But let's say we needed to predict at 200. I was going up by 10, so that's going to go up 10, 20, 30, 40, 50, 50. So I'm looking at something I'm going to assume is up here. If we continued this curve of best fit, that would be my 200. Where do you guys think this would be around? Yeah, maybe like around the 40. Okay, so that's a good estimate. I expect you guys to continue your graph. Okay, so extend your graph with actual measurements when you do it. Try to make the graph better. You got 35? So anything around 35, 40 we'll say. So say a range of 35 to 40. And that's liters per 100 kilometers, right? Because that's what our fuel economy was measured in. And finally, this car does not get very good fuel economy. How would a graph of a car with better fuel economy look? Anyone know what a better fuel economy graph would look like? With all cars, okay, so what this is talking about, in case I didn't quite describe it, this is our kilometers an hour, okay? So, as I drive faster from 10, so as I increase from 10, actually, let's undo that. Let's use that magic line. As I increase from 10 to 200, so as my kilometers per hour increase, you'll notice that this graph at first, when I'm going slow, it's not the greatest on fuel economy. What it's saying is it's burning 15 liters, 16 liters for every 100 kilometers. But as I get up to about here, so it's our bottom of it, I'm traveling about 70, as you guys noticed. I'm going 70. My car only burns roughly 10. It only runs 10 liters per 100 kilometers. That means I'm doing good with my car. I can go farther and farther. So if I maintain that pace, my car is going to get more distance with the amount of gas in the tank, right? So I have a 50-liter tank, let's say, and I'm spending about 10 liters every 100 kilometers. That means I'm going to get about 500 kilometers in my car before I have to refuel the car. But if I'm traveling, let's say I'm traveling at 250, and let's say that fuel economy is around 50, I'm only going to get maybe, for a 50-liter tank, 250 kilometers in my car. The fuel economy greatly drops. So the faster I drive, it looks like, up to a point, the faster I drive, the less fuel efficient my car is. So this is our ideal range. I want to constantly be traveling between 40 and about 100 kilometers an hour. I don't want to be in stop-and-go traffic, but I also don't want to be speeding like a madman because it's going to cost me more money to keep gassing up my car. Homework. Blue notebook, page 272, and that's telling you to go to text, page 166, 1, 2, 3, 4, and 6. And then for the part of the lesson I want you guys to teach yourself, page 274 and 275 in your blue notebook. I want you guys to teach yourself those two pages. The instructions are on those pages. It's very simple. Look it over. Okay, guys?